welcome. Thank you for coming. I'm James Ward. I work at AWS on agentic stuff and MCP. And
I'm Josh Long. I work on the Spring team as the loudest person there.
Okay, great. Thank you for doing that. So we're going to just give you a real quick 25-minute run through of building AI agents using Java. And you may not think like, oh, Java, it's a great place for AI agents. It actually is. Like that's where your business logic is. That's where a lot of your domain logic and a lot of organizations is defined. So why don't we put the AI agents where the data and where the business logic is? So we're going to real quickly go through that in 25 minutes with Spring AI. Spring is a great foundation for building business applications, all sorts of stuff. And they have a great AI package that we're going to use. So what are we going to build our AI agent about? Oh, yeah, and that's our information. That's our slide.
This is the information. Hi, welcome. You can find us online. We're very online. We can find us on LinkedIn. We are YouTubers. Some things we're not proud of, but hey, we do it. We have to look, the hard part about this is what are we going to do as our sample domain? Obviously, you've probably heard about the Spring Pet Clinic. This is a sample application that demonstrates how to use Spring in terms of this very simple domain of like adopting pets and all that, or taking care of pets. And we thought, and I like the domain. I do. I like the idea of dogs and cats and animals and all that.
Everybody loves pets.
Everybody, but sometimes these animals can be a little spicy, and even they deserve a loving home. And this reminds me of a dog about which we learned during the pandemic, named Prancer. Now, Prancer's owner was trying to rehouse this dog, and she wrote this ad that went viral. She said, "Okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not." And she continues on. She says, "There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins." And she continues on, she says, I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. And she continues on, and it's really hysterically funny. You should read the whole thing. But she signs off warning, "Oh, he's only 2 years old and will probably live to be 21 through pure spite, so take that into account if you're interested." So I think about this spicy dog all the time, right? And by the way, super cute. I would totally pet that dog. I'd probably lose a digit, but I would pet that dog. This dog went viral, okay? So here's People Magazine. Prancer, the demonic, come on. Oh, I hate the internet today. The internet is the worst. Okay, Prancer, the demonic Chihuahua's new owner says he's helped her heal from past trauma. So cute, look at that doggo. Here's USA Today. Demonic Chihuahua hellscape, meet Prancer, the puppy everyone wants after a brutally honest Facebook review. And here's BuzzFeed, right? We caught up with Prancer, the viral nightmare Chihuahua, right? And of course, here's the New York Times, local paper, right? Oh, hey,
no, server error.
Cloudflare, what are you doing? Is it that? What happened? I'm gonna try this again.
They just had an unwrap in there,
No! It's my favorite. This is, the website's down. That's sad. Okay, well, anyway, nonetheless, I think about this terrible, terrible dog all the time. I want to build a place where we can adopt dogs, even terrible, terrible ones.
If AI can do anything, it better help us adopt pets.
Yeah, right? Exactly.
That's where we're going.
So that's what we're going to do. And in order to undertake that effort, we need to we need some models, AI models. So let's talk about that.
Yep, so we're going to use Bedrock for this. Bedrock has a lot of different models available. They're hosted, so you can just use them on demand. 249 different models you can choose from in the marketplace of models. So there's the Anthropic models, there's the DeepSeek models, Amazon has their own models, lots of different models to choose from there. So that's what we're gonna use. We've already set up Josh's laptop to be authenticated to AWS, so that part we've already done. So now we can use the AI models from Bedrock.
Now, the reason I like Bedrock is because it's, you have one API, but behind the scenes you can just switch out the models.
Yeah, and just a config parameter, which we'll see in a minute.
So all the Java code we're going to write would be the same no matter which of these models we use in the back end, okay? So I think I'm happy with that. Let's go ahead now and build a project. Obviously, we're going to do that here at my second favorite place on the internet. My first favorite place is and has always been production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you've never been to production, begin your journey here at start.spring.io. And what we're going to do is we have to build a new service. Let's call it an assistant, because after all, that's what we're going to do is we're going to assist people in adopting dogs, right? And we have some choices we need to make, first and foremost of which is what version of Java do we want to use? Look, there are 3 radio boxes here, but only one valid choice. You see, Java's 21 and 2017 are from the distant, distant past, long since deprecated, creaking the old, way past irrelevant versions of Java. You should never ever be using these versions of Java. Instead, only Java 25. Java 25 brings one of my all-time Double Dutch favorite features, which is this. So I'm going to open up this file here, void main, okay, and io.println hi, okay, and I'm just going to execute that. I'm not going to compile it. I'm just going to run it like an interpreted piece of code. And so what I've done is I've executed this code like a script, and the script is written in Java. So you know what this means? You know what this is? This is, in the first time in recorded history, a good JavaScript. Now, this hasn't happened before, right? It's been 30 plus years of the bad JavaScript. Now we have good JavaScript, okay? So much better. So we're going to use Java 25. We're going to bring in the web support. We're going to bring in a database access layer, ORM kind of thing. We're going to need a database, by the way. Which database? I would go for Postgres usually.
Yeah, usually we use Postgres, but we need vector storage, which we're going to get into, RAG and embeddings. So we'll talk about that.
Should I use one of these other vector stores?
There's lots of options, but we're going to use PG Vector. PG Vector is vector storage in Postgres.
Okay, so it's 2 for 1. We're going to get both a SQL database and a vector store in one, but logically they're 2 separate components. It just happens to be we have one server doing double duty. Okay, we're going to bring in Bedrock, of course. We've got both choices.
Yep, so we're picking both Amazon Bedrock and Amazon Bedrock Converse. The reason for that is that the embeddings are going to use an embedding model, and so we use the basic one for that, and then the chat client is going to use the Converse API, so pull in that one. So 2 different libraries.
And actuator for observability, and I think that's it. Is that
MCP client.
Oh, yeah, thank you, sir, as usual. Got my back.
And then memory.
Chat, yeah, there we go. Okay.
So it's just adding some dependencies to how we're going to kick off the creation of this project. So you've created the project, and now you're going to use a JavaScript to open that project.
Darn right.
Yep.
Let's set up some configuration here.
So now we need a little bit of configuration. There's some in here that is going to be revealed as we go. So we're just going to throw it all in, and then we'll explain it as we go.
Right.
But we do need to set the model that we're going to use for our chat with the AI. So we're going to use the Amazon Nova Lite model. Again, that could be any of those 249 models on Bedrock. We're going to use another model for the embeddings. That's the Bedrock Cohere model in this case. So we've configured that. We've had to match the dimensions of that model to our PG vector store. So we set that. And then we set some parameters like initialize the data in the database and virtual threads. Virtual threads are super cool. It's a new feature, a newish feature in Java that makes our thread efficiency much better on the JVM. So we'll use that. We're going to set up our observability endpoint, which we'll show in a little bit.
And then connection to
our
the
database.
All right.
So that's our config. So now let's build our adoptions AI.
It's going to be just a simple chat bot kind of thing, right? So we're going to build a little controller here that answers questions about dogs in the shelter, right? So let's do that. We're going to take a parameter, which is going to be the question, and we'll also have a path variable, which will be the user name, and we'll discover what that is in just a bit. But in order to do this, we're going to take advantage of the Spring AI chat client. Okay, chat client is your one-stop shop for all things working with chat models. And in order to do that, just like anything else in the Spring ecosystem, you inject the builder, build it, and you got an instance of it. I love the chat client. I believe that this is written by the absolute best people, right? The best people worked on this code.
Nice work on that, buddy.
Yeah, thank you. We do our best. So this is this AI.prompt passing in the question .call.content. Okay. Let's see what that spot us.
So that's our super basic ability to receive an HTTP request, take the question from it, pass it to the LLM, and return the response. So in a couple lines of code, we should have a working chatbot. Doesn't do much yet, but we'll add on to it as we go. So what's your question?
Let's just establish brass tacks here. Actually,
just saying hello.
Yeah, although we are going to talk to a database. Let me make sure we have no tables here.
Oh yeah, let's check out our database.
Remember, the goal ultimately is to get the dogs adopted. So I'm going to drop this table. Here we go. Goodbye. And we've got a dog table. And you can see down here, we've got our buddy Prancer. His ID is 45. His name is Prancer. And he's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. And surprising to everyone, no owner. Okay? So,
let's fix that.
Ultimately, we're going to discover this dog and be able to adopt him, right? He's a dog of our dreams or nightmares. So first things first, let's establish the dial tone. My name is Josh. All right, we're connected despite the Wi-Fi, and it says, hello, Josh, it's nice to meet you. It's working, huh?
So that was the request to the LLM. So we responded with that when we give it, my name is Josh.
This should be fine, right? Oh. Why does this always happen? They always forget me. As soon as I talk to somebody, it says, I'm sorry, but I can't tell your name because I don't have access to personal information. That's not great.
Well, so the reason is that the LLM doesn't have state. And so in order for it to remember things, we have to assemble memory that then we wire into the chat client so that then when we make calls, we can pass in the memory. That's essentially just adding more into the prompt that we're going to send over to the LLM. So what we can do with Spring AI is create that chat memory. We're going to use the actual database, that Postgres database that we saw configured to store those memories. There's lots of different ways that you can persist the memories and then different ways that you can provide the memory to the actual chat client, to the LLM. We're going to use the what's it called message window chat memory. So that's going to just create a rolling window through so that we don't save everything forever. We save, I think, what is there a default 20 messages or something like that?
20, yeah.
Yeah. So, okay, so you've configured our chat memory connected to the database. That was a couple lines of code. You're flying. And then we need to tell our chat client about that chat memory. The way that we do that in Spring AI is with an advisor. An advisor is essentially an interceptor so that when a request is going to go to the LM, we can intercept the request, augment it in some way, pass more data, or change whatever is going over to the LLM, and then we can also intercept the response back out. And so there's an out-of-the-box advisor for chat memory, and you already got it working.
Got it working.
Dang,
Easy
dude.
peasy.
Flying.
All right, so we're connected. It's got memory. Life is good. I think we're making good
Oh, do you want
progress.
to show them the table of the memory?
The table? Oh, yeah, there's a table. That's one of those properties that we set up. You saw that here. We said initialize the schema for the chat memory. It's going to store it durably in the table here, and we've got the Spring AI chat memory table. It says, hi, my name is Josh. That's the user. That's us. And then, hello, Josh, from the model, okay, the assistant. And then, what's my name? That's from us. And then, hello, Josh. It's nice to meet you from the assistant. So we have the back and forth interactions in the
So that
model.
was just the default with that memory window way to do that. And we can customize it. We can use other ones, whatever we want to do. But that is just the simplest way to add memory.
Right. I think we've got it. We've got memory. We've got context now. But still, it's a little bit of a sort of unfocused thing, isn't it?
Oh, wait. Did we configure the memory to be per user?
Oh yeah, we should do that. No, we don't. We have no correlation. Yeah, you're right.
So right now it's just like global memory for all users, which probably isn't what you want. So we can go in on our actual chat request. That's where we know what the user is, and we can tell it, all right, pull the user ID out, which was passed in as a URL parameter, and then use that to find the actual right memory. And likely you're going to use security, and you're going to pull out some actual identifier of the user and use that. But right now we just put that into the URL.
It's in the URL right here, Josh. Yeah, exactly. Okay. So that's worked. Nice. Okay, so now it's connected. We have correlation with the identity, but it's still unfocused. And I think we need something to give it a mission.
Yeah, I mean, we don't want people using our chatbot to like do their homework and write code and that kind of stuff. We really want it to be focused on helping people adopt Prancer and other wonderful pets.
Right.
So
let's
let's give it a mission.
Right. I happen to have a pre-written system prompt. That's what we're going to give it, is a system prompt. I happen to have one pre-written here, and we're just going to use that prompt. And no, wait, I'm so sorry. Much
Dog
better.
it. You got to dog that file, man.
There we go. Okay,
Yeah,
got
yeah.
it. So now we'll paste this in here, and we'll configure that here.
So now we just set the system prompt. That's just going to go into the context when we make the request. So what is our system prompt? What are we telling this thing to do?
You are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace, with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. Did I say Antwerp?
We're in Brooklyn.
I meant Brooklyn. Haha. There we are. Oh, no offense. Oh, poor guy, the one guy from Antwerp. I'm so sorry. Oh, okay, well, you know what?
You could have picked Singapore to replace.
I don't know. We could just add, we'll expand. We're a global dog adoption conglomerate. Okay, so now we'll go here. And I guess we just ask it. Like, let's ask it about the dogs, huh?
Yeah, let's find the dog of our dreams.
Or nightmares.
Any neurotic dogs?
Hi, Josh. Currently, we don't have any dogs listed as neurotic. Okay, so it's and it even mentions Pooch Palace, right? It knows it did the assignment. It knows what's up, but still, it's not able to connect us with any of the data because it doesn't have any of the data.
We got our dogs in the database. How do we get them into our AI? So what we're going to do is set up what's called RAG. RAG is a pattern for being able to take data and inject it into the context that we're going to send to the LLM. And so, of course, Spring AI has support for RAG built into it. There's a few things we need to set up to do this. So first, we have to connect to our database. So you're going to add in you've got the question and answer advisor. We'll do that in a minute. We don't have our dog database stuff yet.
Not
okay.
yet.
So we're going to use this question and answer advisor. That's going to be another interceptor that's going to be able to essentially take the prompt that the user entered, and we're going to do a similarity search on that prompt with our dogs. But to do that similarity search, the best way to do that is by taking all of our dogs and taking the prompt and turning them into vectors. And then we can do an easy cosine similarity search that's built into PG vector. So we're able to then match that prompt to the most likely dog, and then we're going to take that dog and put it into the prompt. And that question answer advisor kind of does all the hard work underneath the covers. But we do need to be able to get our dogs out of the database, and then we do have to create the vectors for each of those dogs. So we are going to do that in kind of a cheaty way here. Normally you do that on create and update is when you're going to vectorize, and that's going to go out to the Bedrock Cohere model, get the embeddings, get the vectors for our dogs, and then store those into PG vector. And so Josh is doing that here kind of just manually one-off. We're going to take our dogs, get the vector form. So when we create the document, that's getting a string.
So this is actually a Spring AI document.
Oh, yeah.
But I just realized it's for dogs, so we should call it a document, okay?
Of course.
It's better.
Yep, document.
There we go.
Okay, so we're creating our document, and when we do that vector store add, that's actually going out to the model, getting the vectors, and then putting them into the PG vector database. You want to show the vector? There we are. There's the embeddings. So we got the string, we have the embeddings. Those are just essentially an array of numbers to represent that dog.
And vector stores are optimized to search for that kind of data. I'm not going to vectorize all this data on each restart, so effectively I'm commenting it out.
Yeah.
So you saw that this took a very long time because we had to vectorize all those records.
That was startup and the vectorization.
So I'm going to reload now. Here we go.
Okay, so we've got our vectorized forms of the dogs. We've got our question and answer advisor, and then you added the advisor in?
Yep.
Okay, great. So we've got RAG set up.
Hey Josh, based on the context information provided, we do have a dog named Prancer who's described as neurotic. So Prancer, we found our buddy. We found him.
Awesome.
The dog of our dreams.
Let's adopt that guy.
Well, yeah, but this is text.
Yeah.
If I wanted to pass this data around to other layers of the API, the abstraction, I would want a correlation ID or something. How do I take actionable data out of this unless I'm passing this straight to the user, right? So one possibility is you could turn this text into a actual typed object. So dog adoption suggestion, int ID, string name, string description. And just as a possibility, you say instead of content, you ask for this entity back, right? Here we are, like that. And I go over here, replace that, reload, and ask the same question.
So in a larger agentic system, you're not always going to be passing string in, string out. A lot of times you want to pass structured data in, get structured data out. And so of course Spring AI can allow us to get that structured data out. What's funny is that the LLM put it into JSON, and then we deserialized it into that record, and then we serialized it back to JSON. So kind of silly in this case, but hey,
And I do actually want the string, so in this case we'll keep that. But it's nice to know you can get structured typed objects back, okay? All right, so now, you're right. Let's adopt it. I think the first thing that we'll have to do is figure out when we can swing by the shop. So let's build a tool.
Likely we have like a scheduling system behind this, and what we want to do is wire our agent to that scheduling system. So we can use tools to do this. A common pattern with LLMs is essentially what you're doing is you are saying, hey LLM, here are the things that you can do outside of yourself. They're tools. And so we are going to first define the tool for our scheduling system. We're just going to hard code. We don't have an actual dog scheduling, adoption scheduling system, so we're just hard coding and saying you can adopt it in 3 days. And so we're going to return that from the schedule method. And so now we're going to be able to provide that schedule method as a tool to the agent. And then what the LLM is going to do is say, all right, when the user says they want to schedule to pick up Prancer, then we're going to call that tool. And this is running in process with the agent. So in this case, we'll get to MCP in a second, but in this case, we're actually going to call in memory to this schedule method right here. So we annotate it with that tool. We add a description. That description is very important. Why is that important?
Well, remember when you were a kid and your mom told you to use your words? This is what she was trying to tell you to do, is to clearly document your AI inputs, okay? So that's what we're doing here.
So we do that so that the LLM knows when it should call that tool. So that natural language description, very important. Also for the parameters, the LLM is going to figure out what parameters go in what slots, and so the descriptions, again, are important there as well. Okay, did we get it wired up? Okay, we found Prancer. We've got memory, so now it should know which dog we're talking about.
Yeah.
And we're going to ask, when can we pick it up from the Brooklyn location? And if everything works,
November 22nd. Today is the 19th.
Fantastic. So we know now that it did in fact call our tool. So the way that worked underneath the covers is we made the request to the LLM, we gave it the list of tools, and then the LLM said, oh, I need you to actually call that tool schedule. And so then on the Spring AI agent side, it actually made the call to the schedule tool with the right parameters, and then fed that information back to the LLM, and then got the response back from the LLM, and then that's what we actually sent back to the user. Okay, so but now, maybe you don't want those tools to be in memory. Maybe you've got vendors that are providing MCP servers. Maybe you're taking any of the thousands of MCP servers that are out there, and you want to wire those MCP servers in instead. So we're going to refactor this application, pull out the local tool, turn it into an MCP server, and then wire that remote MCP server up to our agent instead of doing the local tool calling. So you copied and pasted everything in.
Refactored it to use the new annotations.
We're going to set the port to be different because we don't want a port conflict. We did change the annotations there. You can use the same annotations. It just takes a little more setup to do it. But at MCP tool, same description. And MCP inspector, great tool for being able to debug the MCP server. So now we can go look in here, connect up, make sure that 8081.
Computers.
Yep, so we'll connect to that. There we go, we're connected. We can list the tools. We can see that there's a schedule tool, so great. So our MCP server verified in the inspector to be functional. Now we can actually wire it back into our agent.
So that's the scheduler. Let's go back to the code where we now have a dog adoption scheduler shaped hole in our compilation unit. And here we're going to inject a sync MCP tool callback provider. Rolls right out the tongue, easy name, okay?
This is just going to be able to read some configuration for the MCP server or servers that we want to connect to and give us a handle to that. And then we can set in our chat client the hook to that so that then our chat client knows about those MCP servers. Okay, then we need to provide the HTTP URL to connect to that MCP server. So that's just a config parameter, and that looks right to me.
Okay, here we go. Now we're going to try it again. So remember, we have two Java processes running right now. We've got scheduler on 8081, we've got our assistant on 8080, right? And now if I ask the assistant on 8080 for help, it should invoke this tool on 8081. Let's just see that that's true. So, well, first of all, let me clean the cache so we don't have any, sometimes it'll cheat, which is kind of nice, but we don't want it to cheat. We don't want it to
see it in the memory and be like, oh, I figured this out already.
Yeah.
Why redo the work? Okay.
Okay, Prancer, great. Okay.
And remote MCP call. There we go. Okay, pick up Prancer. So then we can verify, yep, it sure enough made that MCP call over to that remote MCP server.
All right.
So great. So end to end, working with MCP, we've got our agent, we've got our memory, we've got our RAG. What else do we have? System prompt.
Yeah, system prompt, user prompts.
Yeah.
And this is the real opportunity here is, remember, it was trivial for us to add all this stuff to an existing Spring Boot application, right? This is just code you probably have in your system, in your organization. That's institutional knowledge that represents years and years of sort of building up, and it's like the grease in a pot that you just keep reusing to enrich the food and the flavor. That stuff is there already. Just add the AI integrations off the side of it, you're off to the races, you're ready to go. This is a really good opportunity for us. And by the way, strongly typed, right?
Yeah.
Nice all the way through. I'm not telling Python, hey, this is a thing I need in this shape. Here's schema. The Java object tells it. It's already enough, you know?
Yeah.
This is an amazing opportunity.
So one of the concerns usually is, okay, great, these tokens are actually expensive. We've been able to get it all working, but how do I get some insight into my token usage?
Oh, good point. You definitely want to keep an eye on that. By the way, we're using Bedrock. It's like pennies. For what we haven't, I don't think we've spent a penny so far today in this demo, right?
Yeah.
We haven't spent a penny yet on that particular service, but you know, you do want to keep an eye on it. So
we're expecting our dog adoption service to go viral. It's going to become the next whale, whatever.
Right.
So we got to be able to observe our token usage. So Spring has built-in support for observability, and it uses something called actuator and micrometer, and it's able to export all the metrics for our application across everything in our application. So one kind of standard observability system, and of course Spring AI integrates into that, and so we can go and look up the token information as an example for how many tokens we've used. How many have we used for this? And this is probably just the current session, so not a whole lot yet. But
request model, here's the type. By the way, this is in memory right here, but it's all powered by Micrometer, which is a third-party API that we built that in turn can be used to publish metrics and distributed traces to any time series database of your choice, including Amazon's CloudWatch.
Yep.
And that's supported here as well.
Yeah, so you can take all of the metric data, publish it externally to your observability platform.
Yeah.
So that's observability.
Yeah, I think, and we've got an application. We still have 2 minutes to spare, I think.
Wow.
We did it.
You're nice and fast.
Well, we took some leisurely turns. We took some time to have some fun with our friend from Belgium here. This is easy. Even I can do this, right? If we can do this, then you can definitely do this. This is an amazing opportunity. So when people say they're doing AI engineering and they get all hoity-toity about it, just remind them, it's just REST APIs. It's just integration. It's the glue code. It's the modern world glue code, right? This is the kind of stuff that Java and JVM developers have been doing as their bread and butter for decades. We are uniquely well positioned here, right? Seize this moment. Take this opportunity to build something amazing.
Yeah. So do you want to highlight the Spring AI 1.1 release and the MCP parts of that?
Just came out. We just released Spring AI 1.1 last week. That's what we used here the entire time. It has full support for the MCP specification, and we are also working. We the Spring AI team. Last November, do you remember November? Because I don't. Last November, when Anthropic announced the MCP specification, we, the Spring AI team, were the first to build an implementation in Java in the weeks that followed, literally the same month, and that got donated eventually. So the official MCP SDK for Java is code that we wrote and then we rebased on. So it's not just the best integration with the MCP SDK, it is the MCP SDK, right? It's just a really, really good specification.
And you can use it outside of the world of Spring. So there's
Sure.
the Java SDK for MCP that's maintained primarily by the Spring team, and you can use that with other ecosystems in Java. You can use it directly, or you can use it in Spring AI, which makes it super easy, as you saw today. So,
Well, I have a question now. Who learned something new? All right, who had fun? Us too. Thank you so much, everybody.
Thank you.
Thank you. Bam!
bam.
So good.